So we begin from where we had stopped yesterday. So today, we look at hypothesis testing. Hypothesis testing. Hypothesis testing. Hypothesis testing, that is what we look at. And we write this. A hypothesis is a pre-existing opinion. A hypothesis is a pre-existing opinion. First of all, hypothesis testing refers to procedures undertaken to determine whether the pre-existing opinion is the reality. The procedures are known as tests of significance. Procedures are known as tests of significance. First up, the following steps are taken. The following steps are taken. One, so what you're saying is, anytime you see a person or anyone, or anything, you develop something we call opinion. Now, this opinion determines the action that you take. And the action that you take determines the results that come your way. The results that come your way. Now, the results are either good or bad. The results are either good or bad. Now, the results are good if the opinion is equal to the reality. And the results are bad if the opinion is not equal to the reality. For example, you can meet a person, and in your opinion, you think that the person is good. And therefore, the action you take is to be near them. But the reality is that the person is also good. So you enjoy the benefits of the goodness of that person. Or you see a person and you form an opinion that this person is a bad one. And therefore, the action you take is to run away from that person. And for sure, you come later on to confirm that the person is actually bad. So the result will be good because you will have been safe now that you ran away. But on the other side, you thought a person is good. So you went near them. But in reality, the person is what? Is bad. So you start suffering. So the outcome will be what? Bad. On the other side, you thought that the person is bad. And therefore you ran away from them. Later on, you confirm that the person is what? Is good. Now you suffer because you will be regretting the benefits that would have come your way if you had not, or if you had known that the person is what? Is good. I don't know that it's making sense. And not only persons, even deals. I remember many years back, I think it was 2009, I got an offer to work with Citibank. And in my opinion, the salary they offered me was not good enough. According to me, that was what? Bad. But many years, including today, when I look back, I wish the same offer could be made. Yeah. So these things happen. Yeah. Not only in terms of relationships with fellow human beings, but even in the deals that you make. Now, none of us would want to get bad results. We all want to get what? Good results. So we must then take time and confirm that for sure what we have seen is the reality. The appearance is the reality. That what is glittering is actually gold. So that you don't follow something simply because it is glittering, thinking it is gold, and you come to learn it is nowhere near gold. Right, so step number one. Step number one, develop the hypothesis. Develop the hypothesis. I'll explain to you. There are two types of hypothesis. There are two types of hypothesis. Roman 1, null hypothesis. Null hypothesis, into brackets, H0. We call it H0. I'll write that this is developed. This is developed to deny the current opinion. To deny the current opinion. In order to generate more information in support of the opinion. In support of the opinion. And the second type is to alternative hypothesis. Alternative hypothesis. Alternative hypothesis in brackets 8a. Brackets 8a. Right, that this is developed. This is developed to agree with the current opinion. Is developed to agree with the current opinion. That one is as simple as that. When you meet a person, or when someone makes a claim to you, obviously in such a relationship, and hopefully if the relationship works, the person will benefit from you. Before you accept the relationship, it is good you confirm whether what they are saying is true. And one of the ways of confirming is to deny. To deny. We normally see this in normal human relationships, especially when a man approaches a girl and he says, I love you. One of the most likely outcomes in the immediate short run, you'll find the girl asking the man or telling the man, I know you bed. I know you bed. Now that is called null hypothesis. Then when that statement is released by the lady, if the man for sure means what he's saying, he starts now giving what? More evidence, more evidence. Mimi nakupenda, mimi unaweza angalia hii, hata unaweza uliza fulani nilikuwa namwambia, I will do this, I will do this. Then unaendelea ukisikiza, and in your own wisdom you go judging whether what he's saying is true or not true. Yeah. Then this one is when you agree. And what I would want to say is this. In life, it is always very good when anyone approaches you for whatever relationship, you start with this one. And I hope I said the other day, when I talk of relationships, it's not just boyfriend, girlfriend. It includes even the one that I have with you. When someone told you to come to Destiny, you don't just come. You need to ask, is Destiny a good school? You need to ask, you need to be informed. Now, there are two ways that most people who want to call you will use to prevent you from developing the null hypothesis. One way is someone coming your way when you're smartly dressed. Let's take the case of men. If you are going to make a proposal, and I'm sure you have seen these things, you don't just go dressed like maybe the way I'm dressed. Si unangana kabisa? Yes, actually there is evidence like those of us who have grown in the village, tulikuwa tunaomba suits. Kama rafiki yako wako na suit na wewe huna and you want to go and see this lady, unaomba hiyo suit. Unaenda unaongea kwa hiyo suit. Then many days after the lady has come, anakuuliza na ile suit nitaiosha siku gani? By the time anakujua ilikuwa ya jirani, she's already beyond the point of what? Return. So when someone comes your way in a smart way, you need to be very careful. I have no problem with being smart. It's very, very important. But anyone who is smart is not to be good. That's why even when you are walking around the streets and the people walking near you are smart, you don't feel threatened. Wait until someone, when you're they start approaching you. Your defense mechanisms are activated. You will start now preparing for anything. Not necessarily that that person is bad. Yes. Yeah. The other thing that people use is by telling you you look familiar. Ukipatana na mtu akwambia you look familiar, you need to be very careful. Because a proposal that is made by a person who is familiar is easier to accept than a proposal from a stranger. Look at what happens even in the normal relationships. If in this class there is a gentleman and a lady, and this gentleman has seen that lady is good and he wants to approach her. What happens if the gentleman is in this corner and the lady sits in that corner? You will find on this particular day, the gentleman moves towards that corner. Hata hakuna salamu, hawaongei. But in the process, in the course of the lesson, unaona anajifanya ni kama hajasikia mwalimu amesema nini, anaangalia hapo kitabu, hivyo. Then before you know it, unaona sasa wametoka pamoja, na mtu amesindikiza mwingine, after maybe several days or weeks, unapata hata namba za simu zimekuwa exchanged. Then unapata one evening or one lunch hour, they have gone out to take lunch together. And nothing is said. Then after some time, your mtu anasema ile iko kwa kichwa yake. Is that so? Yes. But you don't just bump into someone for the first time na unaanza kusema mimi nimekuona nikafikia. It will be rejected. You must first of all create what? The rapport, the familiarity. Because an offer from a person who is familiar is good. Now, this is how it works. When someone tells you you look familiar, they are simply telling you we have earlier on met. It's only that as at now, kichwa yako haikusaidii kukumbuka. And because it looks bad manners, not to appear to remember people you have earlier met. Actually, we take offense. Naona kama venye nimekuwa nikikufunza hapa. Imagine tupatane kwa corridor unisalimie. Nikuangalie nikuulize wewe nani? Would you take offense? Hata kama hutaniambia, would you take offense? Yes, unashangaa. Mwalimu hata kama hujui jina yangu, at least nilikuwa natarajia unajua my face that I'm in your class. Lakini sisi tupatane kwa corridor, nimekufunza for more than 3 weeks or more than 2 months. Alafu naanza kuuliza wewe, are you even a student here at testing? So because hutaki kuonekana hivyo, na wewe vile vile unasema look familiar. When you say you look familiar, sasa unafungua milango ya receive the proposal that has been made. So when someone tells you look familiar, put them to task. Let them know or let them tell you where you met. You see, in my capacity as a teacher, I've taught many people for the last 15, 17 years. Actually, today I was telling someone, I don't think I can go now to any institution that has accountants and I fail to get someone I know. In the accounts department, I've taught for the last 17 years in this city. Taught to very many people. So there are guys who call me, Mwalimu, how are you? Unaendelea namna gani? Ulinifunza vizuri. Sasa siku hizi mimi ni mkubwa kwa hii kampuni. And as a way of saying thank you, nataka mtafutie mwanafunzi nitamwajiri kazi. Have you called me? So I have first of all to ask, with experience I have known, I don't just say, good, niko na wanafunzi hapa wanatafuta internship, wanatafuta job. No, I have learned now the hard way. Nilikufunza nini? Tell me the year I taught you. Nani alikufunza kama ni class kama hii? Nani alikuwa anakufunza economics? Nani alikuwa anakufunza ICT? Mlikuwa mnasoma na kina nani? So when I ask you those questions and you answer them correctly, then I confirm for sure this was my student. But ukianza kuniambia hata sikumbuki huyo, sikumbuki, it can't be. It can't be. So you must be very careful when people come making offers. Very, very careful. Step number 2. Determine the significance level, into brackets, alpha. The significance level, brackets, alpha. This is the amount of evidence. This is the amount of evidence required to reject. Required to reject an opinion. An opinion. In this case, there are four possibilities as shown below. There are 4 possibilities as shown below. That's like a small table. So we have the hypothesis here. We have the decision made. The hypothesis could be true or could be false. You can decide to accept, or you can decide to do what? To reject the proposal that has been made. If you accept a true one, we say this is correct. If you reject, this is called type 1 error. If you accept the false one, we call it type 2 error. And if you reject the false one, we say you have made a correct decision. So those are the 4 possibilities. When someone comes and tells you what they say, it could be true or it could be false. Now, you can decide whether to accept or to reject. If you accept something that is true, we say that is what? Correct. And if you reject something that is true, we call it type 1. If you accept something that is false, we call it type 2. And if you reject something that is false, we say it is a correct decision. Now, some people will tell you that type 1 is more worse than type 2. But for me, I think it depends. It depends. Now take a case like this. You have gone to the hospital and you are complaining of headache. And the truth is that you are not sick. It is only that you have overworked or you have not had enough sleep or rest. But for some reasons, you are sent to the lab for malaria test and it comes out positive. Na upewe madawa. Hiyo ni type gani? Unaumwa na kichwa, so umeenda kuona daktari. But ukweli ni kwamba wewe si mgonjwa, hauna malaria, ni venye ume overwork. And then they put your drugs. Which type is that? It's type 2, because it's false. You are not sick. But they have accepted that you are sick. On the other side, for sure, when you mgonjwa, for sure, uko mgonjwa. Ama ni ugonjwa inaanza. You have been sent to the lab, results have come out negative. So umeambiwa wewe ndio unalala, umechoka. So you are not given any blood. So hiyo ni type what? It's type 1. So which one is more dangerous? Which one is more dangerous? Hauko mgonjwa umepewa madawa. Hiyo ni type 2. Uko mgonjwa lakini umeambiwa aende nyumbani. Hiyo ni type 1. One is more dangerous. Yes. Because when they have told you to go home, they are giving the sickness more time to work on you. But kama wamekupea madawa, most of these drugs will not have any harmful effect as long as your body is what? Is strong. Take this case. Someone has approached you. Let me use now the normal relationships. Someone has approached you and they tell you, I love you, I want to marry you. And it is true, they love you. But where we what they do. So katai. All the person comes, umpime, one ni ukweli, but the fellow is kudanganya, it's not genuine. It does not mean it. Lakini wewe kumpima unaona kama ni kweli anakupenda. So you do what? That's right. Which is more dangerous? Yes, type 2 is more dangerous. When you move in with someone who you think anakupenda na hakupendi, that's more dangerous than kukataa mtu for sure anakupenda chances are there might be an opportunity later on. Because if for sure they didn't wanted you, they may not be quick to move on. So later on, when you realize for sure you may humble yourself and seek a second what? Chance. Yeah. So for me, it depends. Number 3. And maybe I also need to say this before I move out of that. If I have come your way looking for a relationship, as under normal circumstances, you don't say yes, they are there. You don't also say no, they aren't there. Although it is very clear. They can't do what? They can't talk. Yes. But under normal circumstances, you would go out, especially when you think it can work, you will go out and talk to people who would know me and ask them about me. Now, these people that you talk to, they will tell you my good side and also my bad side. You know, you don't even tell them I had approached you. You just pretend to make it too obvious. So who you to compare a very honest what? Opinion. Sasa niambie. Which part would you want the person to emphasize more? Is when they talk of my goodness, ama when they tell you lakini kimani mbaya, which one would you want more emphasis? Let's be very practical. Yusuf, bad. That is, yes, the bad side, yes. Actually, this person would have talked 100 words about Kimani. And out of these 100, 98 they are good, only 2 are, but your focus is that you are hapa. Why? Hapa ndio unaweza umia. Hii kile hatushughuliki nayo. That is obvious. Ikikuwa sawa hiyo, hata mimi naona kama hapo sawa. So hiyo haina shida, lakini hii hapa ndio teacher iko. So that evidence, and you see in most cases, this evidence we normally cap it at 5. Kidogo tu inaharibu. That's why you see even relationships, and maybe you have seen this or you have experienced this. Mmekaa na mtu for a long period of time. Kakitu tu kamoja, kadogo tu, anaharibu the entire relationship. Does it happen? Yes. Because people just focus on this small thing. Unapata mambo imeharibika. Okay, then number 3, to say, determine the appropriate test statistic. Determine the appropriate test statistic. And compute calculated. And compute calculated to bracket CAL. Calculated values. Calculated value. Yeah, by the word appropriate, utaona inabadilika depending on which distribution. You see how they change. Step number 4. Develop the decision rule in terms of boundaries. Develop the decision rule in terms of boundaries. Boundaries are the critical values. Boundaries are the critical values. Critical values. With brackets, CRIT. CRIT. That's the short form tutakuwa tunatumia sana. Still on the same point, the rule can either be 1 tail or 2 tails. The rule can either be 1 tail or 2 tails. So stop, still on the same point. It is 1 tail if the alternative hypothesis has the sign. The alternative hypothesis has the sign less than this one. all greater than. Stop. It is two tails. It is two tails. If the alternative hypothesis, has equal to, or rather not equal to, this one, psi, and that side. Step number 5, make a conclusion by comparing or by rotating the calculated value in the decision rule. So stop. Still on that point, I think NB. Accept means insignificant, and reject means significant. So nimesema hivi, if I come your way looking for a relationship, you will go asking about it. And the people will tell you good and bad. Now, that bad, if it is insignificant to you, you will accept my proposal. But if that bad is what? Significant, you will reject them. And that is brought about to tell you, you will never get yourself into a relationship that is 100% okay. You never get a relationship that satisfies your expectations 100%. And if you find any, you are being called. If you find any, actually when you are negotiating for any relationship, and you find the person is so flexible, anything you ask for, that will be done. This one, you need to be very careful. Hapo utaumia. That person is opening milango yote na madirisha. Kuhakikisha umeingia. Ukishaingia, tajua majuto ni nini. So when you are negotiating for anything, it's like you come to this school, I say, can I pay 1,000? Hey, sir. Can I be in the early morning, sir? Can I be in the daytime, sir? Can I be in the evening, sir? Can I get these notes, sir? Kila kitu unauliza ni, you're very careful. Actually, that's why the student they tell us, when the deal is so good, you do what? You think twice. You cannot get any relationship that is 100%. Even those of us who are married, we are not with our spouses because they are 100% good. They are not, and we know. Maybe you can use I know the shortfalls of my wife. She's not 100% as far as my expectations are concerned. But kulingana na mimi hizo amebakisha, they are what? Insignificant, and that's why nimekubali tukae na yeye. Hata yeye ukamuuliza saa hii, atakwambia bwanangu si 100%. Kuna maishu, niko na mashida zinakusukuaga kwa kichwa, si ndio? But according to her, they are what? Zikikuwa significant, then that relationship cannot work. Even in a class like this one, hii relationship niko nayo na wewe, usijidanganye ama nisikudanganye ati ni 100%. Kuna time nakasirika na wewe. Vile kuna time hata unakasirika na mimi, unashangaa sasa huyu mwalimu shida yake. But those things, they are what? insignificant. That's why bado tunaendelea kukaa pamoja. But if they become significant, then we cannot continue. Those are things that we need to really appreciate. Because there are other people who will always miss out when they go looking for 100%. We call them the perfectionists. They are the fellows you agree that unapatana at 5 for a cup of tea. Then you come at 5:05, unapata hata chai. Na kama utampata hata hakuna salamu, ni msomo. Kwani wewe una saa, huko unajua tulikusema hii, sasa mkianzana hivyo na makelele, hata hiyo kikombe ya chai kitakunywa tu sababu imelipiwa, then ujipatie shughuli. So it can't be 100%. Then last step, number 6. Interpret the conclusion. Interpret the conclusion. Yeah, here sitaongelea, I think I will talk about it when we have a question. That's when it will make sense. So those are the steps, and I think now we can get to the questions. So there are steps that I gave you yesterday of how to judge a question. So we are still going to apply them. So to say, they apply to any question on sampling theory. Sasa, Yusuf tusomee question 1.
Sugar divider bags sugar into bags weighing on average 1.1 kg with a standard deviation of 0.01 kg. A sample of 16 bags is taken at a random from production, and the mean weight is found to be 1.01 kg. Is there any evidence to suggest that the feeding machine has drifted from its correct setting?
Thank you. That's good. That's good. So we already know that we are dealing with you are not here yesterday. We already know that we are dealing with hypothesis testing. So I told you the first step ni kujua, is this question on hypothesis testing or confidence interval? Now, this question is on hypothesis testing because you can see they are saying, is there any evidence to suggest? Now, evidence comes from the test of significance. Number 2, I told you you judge whether population is known or unknown. So is this population known or unknown?
It's known.
It is known. Good. We can see the delta. So, and we can known population. Known population. The second thing or the third thing I told you to get is to know which measure is involved. Are we dealing with the mean, with the proportion, or with the variance? Tuna test nini? We are testing the mean. Good. And then, is it SIGO or 2? Or there are 2? 2. Why?
Yeah, 2.
Which one and which one? Or how many samples do we have? Jana tulikuwa tunasema sample. Have you seen that? Okay. You see that one? The second sentence, sample. The second line. Hapo ndio nilikuwa nakwambia that is singular. So you're dealing with the SIGO. Yeah. SIGO. So with that, the first step now is called hypothesis. Now tell me, if I ask you, have you seen my phone? Do I have an opinion in my head? Which one? You have stored it or you could have seen it. See there? Yes. Otherwise, if I don't have the opinion that you could have seen it, I cannot now come asking. Sasa, in this case, the question says, kuna hii kampuni yenye inatengeneza sukari, and they have been putting their packets in kilos of what? 1 kg. See there? But sasa, they want to check whether the machine has drifted. So mwenye anakuja kuchunguza whether the machine has drifted, what is in his mind? Use the words of the question. The machine? Yes, the machine has drifted. Yes. The machine has drifted. So that is what now we call the current what? Opinion. So kanusha hiyo. The machine has not drifted. So tumesema the null hypothesis inakuwa ya kukanusha. So unakuja hapa useme the sample mean is equal to mu. That is, hii sample ilipatikana na mean ya what? 1.01. 1.01, it is the same thing as 1.00 because the machine has not drifted. That's the meaning. Hajabadilika, so zinatoshana. Then in the alternative, you now agree that the machine has drifted. So you say X bar is not equal to mu. That is 1.01 is not equal to 1.00. Step 2. Significance level. Significance level is alpha, which yesterday we said it is what remains for you to go to 100. It is what remains for you to go to 100. So what percent is given there, or what is our alpha there? Umeambiwa you test at what percent? Or they have not given, eh? So unaweza ongezea hapo kwa swali ama bidhaa assume 0.05. Most of the questions utapata zitakuwa 0.05. Next is test statistic. Now, when you are in, when the population is known and you're dealing with a single mean, the test statistic in a Z, which is given as X bar minus mu, you divide by the standard error, which we said yesterday is given as standard deviation, you divide by the root of that. Then from there now, you substitute these values so that you get what we have called calculated. The value, X bar, which is 1.01, mu, it is 1.00. Standard deviation, tumepewa ngapi? Standard deviation of the population, tumepewa 0.01. 0.01, you divide by the square root of the sample size is what? How many items are involved? 16. 4 positive, eh? Okay, 4. The next step is called decision rule. And this one, you see the sign of the alternative. Unaona hii? Tumesema kama umeweka this sign, it is 2 tails. There are 2 tails. Two tails test. So 2 tails huwa inachorwa hivi. So this side huwa tunasema you reject null. Hapa huwa tunasema you accept null. Hapa tunasema you reject null. And this side here, it is alpha. This is 0.025. This is 0.95. And this one is 0.025. So this is minus Z critical. And this is positive Z critical. So, chukua your normal tables. The normal curve, the normal probability distribution tables. And when you go to the tables, just like you see yesterday, unaona hii ya huku, utaenda kutafuta 0.5 minus 0.025. Remember this 0.025, it is this alpha divided by 2, because you are doing 2 tails. So this is 0.475. Na hii I think hata tulikuwa tumesoma jana. So hii tulikuwa tumesoma jana tukapata 1.96. Si ndio? And positive 1.96. So we are going to tuendelee. So hii nimeisaka because lazima ushike mkia, okay? Yeah. Then from there now you make conclusion. Conclusion, this is how it's done. Put it this way. We all want relationships. And before the person comes, kichwa yako ishaweka sheria. Yule mtu tutapatana na nimkubali atakuwa na hii na hii na hii na hii. Is that so? Ama ile shule nitaenda kusomea itakuwa hii na hii na hii. Sasa hiyo ndio inaitwa the rule. Ushajiwekea mipaka. That's why at times when men approach ladies, I think they will tell you are not of my time. When you're told you are not of my time, amekuwekelea kwa hii rule, akaona wewe uko kwa hii region ya ku reject. You don't fit. Now finally the person comes to you. You go now gathering data. When you gather data, hao watu wenye umeongea na wao wamekwambia hiyo maneno yote wamekwambia. That is what we call the calculated. Sasa unarudi kwa sheria zako. Nimeambiwa hii na hii. Does it agree with what I wanted? Iko kwa region gani? So nataka uniambie hii 4. Ukiwekelea kwa hii line itakuwa wapi? This is a number line. Ukiwa hapa ni minus 1.96. Ukiwa hapa ni 1.96. So 4 ukiambiwa utafute 4 iko wapi? Siko huko juu. Where we are told to do what? We are told to 4 seat iko na huko. Na hiyo region ya kufanya nini? Ni reject. Tazoea tu. You reject now. Since Z calculated is greater than Z critical, that is 4 is greater than 1.96. What does that mean? Siwaongea na watu ukasema your position and someone is left asking me meaning. So unastahili kumwambia exactly what you mean. Meaning the machine has drifted from the correct setting. From the correct setting. So that is how we do the hypothesis test. So we take a small break for prayers.
All right. This one. So you were asked if the machine has drifted or not.
Yes.
And then you say when the machine has drifted. Using that. Me. Oh, me. I think it is this alpha x bar or x. This x bar. You see x bar. That's me. You see, on the bottom show me with that one. And also X bar or that U means you. Those letters.
Okay, so okay. So we now proceed. That is to submit question 2. Now, before we read question 2, look here. Look here. I said this one, x bar is not equal to me. This, you can see, is not equal to 1. here you are free to decide. Unakuanga na two options. You can either say that they are not equal, or you can specify the direction of the difference, whereby you tell us that 1.01 is greater than 1. See, that is also true. Yes. So if you decide that, then you tell us X bar is greater than mu. Now, ukifanya hivi, when you come here, it will be 1 tail. It will be 1 tail. So you just shade one side. So you are free. But when you are marking these questions now, what have you put here? Then how have you designed the rule? And then how do you make the conclusion at the end? So you are free to tumia either this one or this one. But sasa hapa huwezi tumia ile ya less than, huwezi tuambia now 1.01 is less than. But kama tuseme ulikuwa na 9, which you had initially told us is not equal to 10, which is true, you can also tell us that 9 is less than what? But now huwezi kuja utuambie 9 is greater than this. So this one inakuanga na two choices. Either utumie hii side ama one of these. So ukifika hapa, either utafanya 210 ama 110. You are free to decide. So that is it for us.
Machine makes the holes in the ocean. The machine is intended to validate so that the hole is on average 4.00 with a standard deviation of 0.200 millimeters. A sample of 25 washes is selected at a random, and the mean diameter is found to be 3.8 millimeters. Is there any evidence to suggest that the machine has differed from its correct setting?
Thank you. Thank you. That's good. So as usual, is the population known or unknown? No. It is known. Good. So I think a known population. Known population. After you write known population, are we dealing with a single mean or two means?
Single.
Single. It's a case of single. So andika hivyo. Known population, single mean. The opinion that is there is that the machine would have drifted. So we are told when you deny, actually you can just grab this thing this way for now. I know about that if you are not able to get that now. So here, unasema X bar is equals to mu. That will always remain in most of the cases. That is, the sample has a mean of what? The sample has the X bar. The X bar imepatikana 3.88. X bar is 3.88. So nasema it is equal to the 4.00. Then X bar, so angalia hapa. You check here now. You decide whether utasema they are not equal or utasema it is on inside. You see this is smaller. So you say X bar is less than mu. That is 3.88 is less than 4. So significance level, still put 5, 0.05. Test statistic, the formula remains. The formula remains. So if the formula remains, then this one I have 3.88 minus 4.00. The standard deviation is 0.2. You divide by the root of 25. Negative 3. So this one, it is going to be a one-tail test. It's going to be a one-tail test. So I told the so the whole of this now is 0.05, and here is 95%. So here we are not dividing. So this one, when you are on the lower side, you have a negative minus Z critical. That's what I want. So tumesema hapa that when you go to the table, you are going to look for 0.5 minus 0.05, which is 0.45. That is what you're saying. So chukua your tables. Ingia huko ndani utafute 0.45. You may not find it exactly, but pick the one that is closest. Have you seen it? Have you seen it? The one that is closest to 0.45, eh? 4495, eh? So you can either take that 4495 or 4535, eh? So I want to go with the 4495. So what is on the right hand side? Sorry, on the left hand side, the row, is 1.6 na column ni 4. Not able to see it. Uko ndani kwa tables. Na unasoma nani? One number 0.45 out of 1.6. Z ndio normal. Kiona Z ni normal. So it is minus 1.64. Right. So let's make the conclusion. Conclusion tasema sasa kuja uangalia hii 3. Hii minus 3. Ukiweka kwa hii line, where is it? Is it on the lower side or the upper side? Negative 3. Iko na huko, sio? So then we will say reject null hypothesis since Z calculated is less than Z critical. That is minus 3 is less than minus 1.64. Meaning the machine has drifted. The machine has drifted from the correct setting. Yusuf, read for us question 3.
The day to which a variety of plant grows in a nursery man's plantation is approximately normally distributed with a mean of 53 centimeters and a variance of 12 centimeters square. Last year, a box of 15 of these plants received by a mistake doubled the liquid fertilizer. The mean height of the plants in this box was 55 centimeters. Is there any evidence to suggest that the extra fertilizers has had a beneficial effect?
Thank you. That's good. So the first thing is the population known. No. It is not known. Yes or no? No. No. You cannot see delta. Can you see delta there? You cannot see this side. Can you see it? It is there. Au unasumbuliwa sababu iko delta square. Hiyo ndio inakusumbua. Hiyo ni variance. Na unajua tukiwa na variance, we need to just square it. To get the square root. I told you it is either if it is known, or rather if it is absent, there is information that can help you compute it. So hakuna delta per se, lakini tuko na hii. Si hii tutafanya square root. Ndio tupate hii. So it is also a case of known population. And a case of single mean. Known population and single mean.
Does it this mean when the denominator is small?
Yes. You did not attend yesterday's class, eh? Or you have what you are saying. So hypothesis. So I've told you the null hypothesis, you always write this. X bar is equal to mu. X bar. So sasa hii kasample ilipatikana with a mean of 55. That is 55 is equal to the box should have had 53. That is mu. The alternative is that X bar is greater than mu. That is 55 is greater than 53. You can see that very clear. Yeah. From there, tunaweka significance level. Significance level. So hii tunatumia alpha as 0.05. From there, tunaleta test statistic. So test statistic, that is what? Z is equals to X bar minus mu. You divide by standard deviation, which is divided by the root of n. So Z calculated is 55 minus 53. You divide by the variance. Variance tumeambiwa it is 12. So you get the square root of 12, which is divided by the square root of the sample size. The sample size is 15. The sample size is 15. What is the answer? 2.24. I tried to show you now the decision rule. Decision rule. And this one is one tail test. One tail. So one tail, we normally shade, or we are going to shade. Unaona, angalia hapa eh. Unaangalia hii ina point wapi? Unaona inasema the other side, the higher side. Ukiangalia hata hiyo ingine ilikuwa inasema the lower side. Tutashade na huko eh. So this is to reject null, and this is 0.05. Then here we will say accept null, which is 0.95. Na hii ni ile Z2 tumesoma, so we just go straight positive, kapata positive 1.64. It is the same. The only difference is that this one is positive and the other one was negative. Conclusion. Hii iko side gani? On the upper side, so we reject. And so far, all of them have been telling us reject. So please don't cram that kila mahali takuwa reject. It's only a coincidence that so far they are all saying reject. Yeah, you know, some of us are very strong in cramming. So we reject null since Z calculated is greater than Z critical. That is 2.24 is greater than 1.64. It's greater than 1.64. So the meaning of this is that the extra fertilizer had a beneficial effect. And a beneficial effect. That's okay, eh? Ready to submit question 4.
This slice PNC produces straight bars. One particular type of bar, it has always been claimed that the expected lifetime is 1500 hours. In order to place a new batch, a sample of 10 was taken. The mean lifetime of the sample was 1410 hours, with a standard deviation of 90 hours. Does the evidence suggest that the expected lifetime has changed from 1500 hours?
Thank you, that's good. So again, is the population known or unknown? Yes or no? Known. Can you see this one?
Yes. But you see this?
Yeah? No, I'm asking, can you see this?
No.
Then it is unknown. Yes, that they are insistent. Why you need to be very clear. It's not just standard deviation, but which standard deviation. So unknown population. But the question is about a single sample. Eh? So it is single mean. We are comparing a single mean. So safari yanze. Hypothesis. In the hypothesis, I've told you this one, you should always put it that X bar is equals to mu. That is, hii ilipatikana as 1410. Ndio tunasema it is equal to 1500. And the alternative is that X bar is less than mu. That is 1410 is test statistic. Alpha is 0.05. Oh, sorry. Hilo ni tunaita significance level, not test statistic. Significance level. So huyo mwingine ni test statistic. So this one is T, and T is given as X bar minus mu. You divide by S, which is divided by the root of N minus 1. So the formula now has changed. So let's compute the values. T calculated now is 1410 minus 1500. We divide by the S here is 90. So 90 is to be divided by the root of 10 minus 1. Negative 3. So decision rule. So this decision rule is one tail, and if it is one tail, it is going to have 10 minus 1 df, degrees of freedom. 10 minus 1 df. So, because we are on the lower side, we are going to shade here. So this is to reject null. This is to accept null. Then here you have minus T critical. This side is 0.05 because it's one tail. Chukua your T tables. Zile tulikuwa tunasoma jana, the T tables. The students T table. Yes, Paris. You can type or you want to speak. Let me allow you to speak. You can speak, Paris. You can unmute yourself. Okay, or maybe the sign is by mistake. Okay, so the tables we had yesterday, tulisema you start from the right hand side where there is that kahani. So in this case, you are going to go to where there is 110 confidence. Can you see the 110 confidence? 4 of that line has moved to the left and stop where you have 95. This is 0.95. You are there at 95. Then go down where you have these degrees. 10 minus 1 is 9. Tell me what you find there. 1.8? Huh?
331.
331. 1.8, 331. So let's make the conclusion. So the conclusion is you check this one. Where is it? Again, on the side of rejecting, is on the lower side. So reject null since T calculated is less than T critical. That is minus 3 is less than minus 1.8331. The meaning is the question was asking whether the expected lifetime has changed. So the expected lifetime has changed from 1,500 hours. So we are okay. Now question 5, that one you shall do on your own. And what you shall do, that question 5 has not computed this X bar for you. You have been given instead the Kina 247. So you know how to compute X bar. It is the sum of the Xi's divided by what? Yeah, so kisha compute the X bar. Ufuate hii taratibu. Hiyo swali inafanana na hii. So leave a space equivalent to what this one has taken. Please read for us question 6.
A supplier of electronic components make a product which sometimes fails immediately to be used. The supplier tries to control his manufacturing process so that the distribution of quality products is less than 4%. A batch of 500 components is applied and 28 to be quality. Is there an evidence that the manufacturing process has gone out of control and too many quality products have been produced?
Thank you. Think that's good. So that question is a case of unknown population. You cannot see delta. No. It's a case of unknown population. And it is a case also of a SIGO proportion. SIGO proportion. SIGO proportion. SIGO proportion. So with single proportion, first of all, the examiner has not computed for us the sample proportion. So we need to compute that one for ourselves. P is the 4%, and 4% is what we call 0.04. It's not every question that we have computed for you. Just like we have said in question 5. Then the sample proportion. The sample proportion to my viewer, it is 28 out of 500. So give me that. $0.056. So if you had not provided with those values, you compute for yourself. Haya, sasa tuanze safari, andika hypothesis. Hypothesis. So in the hypothesis, the null hypothesis will be saying sample proportion is the same thing as the population proportion. That is 0.056 is the same as 0.04. When you come to the alternative and you deny this, you'll be saying that the sample proportion is greater than the population proportion. That is 0.056 is greater than 0.04. It's greater than. So if it's greater, then we go to what we call significance level. So again, alpha to be 0.05. Test statistic. Test statistic. So test statistic is Z, but now Z is computed as alpha. Sorry, not alpha. It is the sample proportion minus population proportion. You divide by the square root of sample proportion, 1 minus sample proportion, you divide by n. So Z calculated will be 0.056 minus 0.04. You divide by 0.056. You divide this by 500. You divide by 500. What's the answer? 4.54. 1.54. So we come now here and make our decision rule. And this decision rule is one tail. One tail. Sasa itakuwa namna hii. Because we are saying it's on the upper side here. So this is 0.05. And here we shall reject null. And here we shall say accept null 0.95. So this is positive Z critical. Na hii tumekuwa tukisoma tukasema ni positive 1.64. We have been getting it from the tables. So with that, we now make the conclusion. What do you think? This 1.54 and this? Where is it? On the lower side there. Good. So at least now you can accept now. Since Z calculated is less than Z critical. That is 1.54 is less than 1.64. What does that mean? Swali ilikuwa inauliza, is the manufacturing process gone out of control? The process has not gone out of control. The process has not gone out of control. So with that, we call it a day at that juncture. Call it a day at that juncture and hope to pick up from there.